is extremely important for developing projects in STEAM using different skills at many levels. What we will be starting with is the PowerPoint that I've prepared in order to simplify a little bit the task for you. This PowerPoint, just 1 second. All right. This PowerPoint will be shared with you by the end of this webinar. Just can you confirm me if you can see my screen, my shared screen in PowerPoint?
Yes, we can see it.
Yes.
Okay, great. So today what we are going to explore is how to create a STEAM project in order to build a rotating solar panel. By the end of this webinar, you will be able to use Arduino and Tinkercad 3D skills in order to create this project. And if you remember, I asked you in the Google form if you have a 3D printer at school or not, since we are going to implement the 3D design in order to create the skeleton for the rotating servo motor. So I'll be starting by what we will be using for this project. And I believe that if you can, let's say, understand the way things are done in this project, I believe that other projects will be similar to this project. So for this project, we will be using Tinkercad circuit to design the Arduino circuit and to understand the different components that we are using. Tinkercad 3D to design the skeleton of the servo motor and the rotating panel. Of course, Arduino software and the 3D slicing software to print on a 3D printer the skeleton. I believe that if you don't have the 3D printer at school, you can get the design. You can, I'm recording the session, and by the end of the session, also you'll be receiving the recorded video. So no need to record it from your side. Okay. So so I believe that there is now companies in Saudi Arabia, and I'll be asking for a few of them to provide you maybe later with the addresses, just in case you want to print a 3D design in order to implement it in the STEAM project. So regarding the hardware, what we will be using for this circuit. So I believe that the components are really clear. What we will be using is an Arduino board, of course. We will be using a breadboard in order to create our circuit. We will be using a servo motor, and will be checking for the characteristics of this servo motor in order to make the solar panel rotate to the left or to the right, following the light of the sun. We will be using a sensor called the LDR, and this sensor will be reading the intensity or the quantity of light, and from there we can decide the orientation of the solar panel. From this sensor LDR, we will be using two sensors. We'll be putting one on the right and one on the left. And then we will be making like the flashlight of the cellular as a demo in order to make this system working correctly. Of course, we will be using a multimeter in order to measure the value of the resistors, since there is a specific value that we are going to be used or to use. We will be using two resistors, 10K ohm, just in order to complete the circuit. And of course, we'll be using a male-to-male jumper wire in order to create all the connection. Now I'll be moving to how the circuit is designed. So I'll be going in a while on Tinkercad circuit in order to show you live how to create. And for those who don't know really Tinkercad, I'd like to tell you that Tinkercad is a software, is a platform. It's an online platform created like a few years back during Corona in order to facilitate the task for teachers and students in order to learn circuits and 3D design. And it's free. It's free, and this is how Tinkercad lead the market now by simplifying the task of making Arduino skills, let's say, easier for students and teachers to learn about this technology. So what you can see in this just one second. What you can see in this circuit is an Arduino board and a breadboard. You can see the two, just one. All right, all right. So you can see the LDR with the resistor from the left, another LDR with another resistor from the right. You can see a servo motor, okay, and of course the breadboard. So the three components that we are going to build on the breadboard are the LDRs with the resistors and a servo motor. Of course, we are going to explore it live and technically to show you how to build it and how to link it to the Arduino board, since we are going to move to Tinkercad in a while. So how the LDR works on the in a real project. So when the light is low, it's night, or the light is low, the value of the LDR is really high, as in terms of data reading. It works in a reverse way. And when the light is high, the LDR reads a low value. So you have to understand this concept in order to make students understand that when the light is high, the LDR is reading low, and the opposite is also true. So this is what you have to know about the LDR. The two legs
Sir,
of the
sorry for that.
LDRs are,
Excuse me, sir. Excuse me,
sorry?
sir.
Yes, go. Yes.
Please switch off all the cameras for the participants from your side, because some of them are not sophisticated users, so they leave their cameras open and they might be exposed to others. So
right,
please,
sorry,
all the camera, switch off
just one
all the
second.
cameras from your side, and even
just,
the microphones as well. Thank you.
Yes.
Thank you.
Just give me 1 second in order to. It's in the setting, I believe. Just 1 second, please. participants. Can you guide me? I really forget how to switch off the cameras.
So you can go to the videos and click on switch off or stop videos for everybody, for everyone, for the participants.
Sir, you can stop it from the down there, the tab. You can switch it off from there.
From where? Sorry.
If you are a computer
You
user,
can go
so
to the
there will be a
participants.
the participant side. Like there will be a mute, participant, chat.
Mute
From
all,
there is a camera.
or even you can click them all one by one if you don't have the option
But
to
I have
switch.
64. I have 64.
On the top, there will be an option to switch camera for all.
I'm looking. Just 1 second, please.
No problem, sir. Take your time.
Let me stop the sharing.
Even though, sir, the cameras are off now.
No, because it maybe. Oh my God. Honestly, I'm a little bit lost. I don't know why.
No problem, sir. Take your time. We are here with you.
Enable. So I have all my all. If you can. Oh my God. So.
So we will switch off the camera, so no need
So
for.
please,
you to
can you all
stop
switch off
it.
your cameras and your microphone? I'm still searching.
Yes, sir. We have switch.
You can
We have switch off all our cameras.
Meeting options. You can find the option there. Meeting options.
Meeting options from where I can.
Yes, I already sent a picture, a screenshot.
Just 1 second. Excuse me, I'm a little bit confused, but
Sir, everyone have closed his camera. Just carry on. We'll close it.
oh, okay.
Only we have 65 people, 66. So all the cameras are now turned off.
Turned
Only
off,
I think
huh?
one person.
Okay, great. Just 1 second. So I have to share another time my screen. So
Yeah, you have to share the screen. Yes.
yes, sharing my screen.
Yeah, now it's working. Your screen now we can see.
And then go to PowerPoint. And
Yes.
I was saying that the
How to connect?
the characteristics
Yeah.
of the LDR is
Yes.
when the light is low, the value of the LDR is high, and the opposite is true. The characteristics of a servo motor is like to this servo motor can turn 90 degrees to the left and 90 degrees to the right. So in total, it can turn 180 degrees. And usually this servo motor has a characteristics of controlling the rotation of the gears inside by degrees. So you can order this servo motor to turn like 5 degrees or 7 degrees or 90 degrees. And usually what you have to explain for your students is that this servo motor is used in real life for what we call the sliding door or a barrier gate or a rolling shutter. So any movement that needs a control of the movement will be integrated with a servo motor. So that's why in our project we will be using a servo motor. So as a recap, the two items that we are going to use are the two LDRs, of course, with two resistors of 10 kilo ohm, and I'll be explaining later why 10 kilo ohm, a servo motor of 180 degrees, and of course, in order to control our system, we need what we call an output display. And as you know that there is no screen built on the Arduino board. So on my Arduino board, I don't have a screen to see the result of the reading or any kind of information to make sure that our system is working correctly. So here we have to go for the option of even installing an LCD screen that you can see on your monitors, or to use what we call the built-in serial monitor. And here, from the picture that is in front of you, you can see that building an LCD screen, it's really a hectic procedure. It's really complicated, simply because there is too much wires that we have to connect. And I believe that we don't have enough time for that in a classroom, or maybe for the 45 or 50 minutes. It's impossible for students and even for you to create this kind of circuit. That's why we are obliged to go to the serial monitor. And I'll be moving to can you tell me if you can see my Tinkercad screen?
Yes, we can see, sir.
All right, great. So I'll be opening my circuit that I've already built in order to cut it short. So you can see now our solar system, right?
Yes, sir, we can see it.
Okay. So,
Yes.
Let me explain you, for those who don't know, in like 2 minutes, the concept of the Arduino board. So the Arduino board is made in a way where you have pins on the upper side and pins on the lower side. This is first. The pins are that you should know are the digital pins from 0 to 13. You have the ground pin, which figures on the top row of the pins, and even down you have two ground that are the same. I have the 5-volt pin, and I have what we call the analog pins. So what you should know between the difference between the digital pins and the analog pin is very simple. So here you have all the digital pins, and then here you have all the analog pins. So by choosing or knowing the difference between the digital pins and the analog pin will allow you to understand when to use the digital and when you use the analog pin. So as you can see here, the LDRs are related to the analog pin, and it's normal since the analog pin has the ability to read like data or values from 0 to a certain amount. So it can read 5, 4, 6, 7, 8, 800, 700. So it's a curve of values that the analog pin can read. The digital pins are pins where they can read like, let's say, two status, which are on or off, 1 or 0. So what we are going to see now is how to build the circuit. So I'll be placing two LDRs from the left and from the right. And since the LDR has two terminals, so from one side, and this is very simple from the way I'll be explaining to you, from one side, okay, you will be connecting the LDR to the ground pin. So this cable that I have selected, it is connected from one side to the ground and from the other side to the first row of the breadboard. So each time I connect from using a cable from any of the pins here, it means that it's connected to the ground. So I need 3 grounds. That's why I choose to connect this ground to the breadboard, and then to select or to connect the first LDR for one terminal, the second LDR also for one terminal, and
بس اللي هلا وانا واقفه والله هني عادي
sorry, can you turn off your mics لو سمحتوا? Can you turn off your mics, please? All right. As I said, from the ground, I'll be connecting one terminal for the first LDR, second LDR, and then for the servo motor. And it's really clear for the students how to connect, since once they place the mouse on one pin, it will shows you if it is for the signal, if it is for the 5 volt, or for the ground. I don't know why here it's not showing. Okay, the power. This is it. All right. So I'll be connecting again. It's okay. Okay. From one side of the LDRs, it's connected to the ground. From the other side, you will see that there is a connection from the upper side and from the lower side of the second terminal. So let us see clear how it is connected. So this is my LDR, and it's always like this. So what you are going to do is to connect from one side of the terminal 2 to the analog pin 1 or 2, and from the other side, it will be connected to the 5 volt. And I'll be explaining why this circuit is made like this. And here, I'd like to open a bracket to say that we are an ICT and STEAM teachers. So sometimes we miss some information regarding electronics and electricity. So don't be disturbed if students will ask you about a specific concept, and if you don't have the answer, since you can tell them that they can go to their physics or electricity teacher, and ask them about a specific logic, why we are using this or that. Okay, so why we are using a 10 kilo ohm resistor? Simply, and this is the answer that you should give to your students, simply to cut short any small signal of electricity in order not to pass through the LDR. And why we put it? Because if it is not here on the breadboard, even small signals of electricity, okay, can pass through the circuit and they will disturb the functionality of our circuit. That's why by putting this resistor, we are sure that no parasite, let's say, or no lower value of current will pass and will disturb our system to function in a correct way. So, excuse me, sorry. Excuse me. All right. So now it's clear how to create my circuit regarding the LDR. I repeat, from one terminal, I'll connect it to the ground. From the other terminal, from one side, I'll place a resistor. From the other side, I'll place a cable to connect it to A0 and to A1. I can connect even to A2, A3, or any of those analog pin. So, and from the other side of the resistor, it will be connected to the 5 ground. This is what you have to know about the two LDRs. Now for the servo motor, you can see that you have 3 pins. You have the signal pin that is connected to the signal. You have the power cable to be inserted in the 5 volt, and the ground will be connected to the same row of the ground. Now, if we'll take a real servo motor, you can see that always there is 3 cables, and there is like 3 intensity of colors. The darker one, which is the brown, it is always, or maybe sometimes it's the black. So the darker one should be connected to the ground. The middle, which is usually a red, it's the 5 volt pin, and the lighter color, which is the yellow, is connected to the signal pin. So this is how your circuit is built. And I believe that if you have the hardware at school, because many of you showed me that there is told me that they have already kits of Arduino at school. Let me check. Okay, Mr. Amr asked me why we need a resistor on the other side of the LDR. I've explained that what is the role of the resistor is simply to minimize the flow of the current. So if we do not place this resistor, the flow of the current will always pass and will always, let's say, disturb the well functioning of this circuit. So by placing this resistor, we are sure that we can control the functioning of our circuit by the program that we are writing on C++ that we are going to explore in a while. So that's why this resistor is embedded in our circuit. And I can ask you, if you go on YouTube or any resources that are on YouTube or on internet, and you'll explore how to build a circuit in order to make an LDR function properly, you will see that a resistor of 10 kilo ohm is embedded in our system. So we have to admit and to accept it. And I remind you that we are ICT and STEAM teachers. So I believe, I'm talking about myself, I don't have enough background of electronics and electricity to go further than what we are saying, and especially in front of students, we have to admit that we have to be flexible and to tell them that for more information they have to go and discuss this issue with their science teacher or physics teacher. All right, so this is what we call the circuit. And I believe that if you have a basic skills in Arduino, you should be capable of creating this circuit. The colors of the wires is not really important. So if you are going to, let's say, to take a set of cables, just the colors are to make, let's say, the circuit a little bit clear for you in order to follow your lines and how things are done. So I'll be moving to, I remind you that I'm working on the software Tinkercad, which helps me to build my circuit, to show it to my students in a clear way. And then once I go to the right section of my platform Tinkercad, I can see that I have like buttons. One of the buttons is the code, and the other button is start simulation. So before start simulating my circuit, I'll be clicking on code, and you can see that I've already built my circuit, which is a block-based code. And why we have to go to such a solution especially for the intermediate class, since for those who are using our curriculum 01, they know that Arduino is embedded since grade 7. And we believe that in grade 7, students are a little bit like beginners in this field. So we cannot ask them too much things at the same time. So we have to simplify the task for them in a way. That's why once we show them the circuit built on Tinkercad, they can do it, they can copy it, they can modify it, they can innovate, they can create another scenario. And when we go to the coding part and we build the solution or the script as code, I believe it will be an easier step for them in order to implement this circuit altogether. So if we are going to see a bit what are the blocks included in the script, it's really simple, it's really easy, since I believe students are used to the scratch programming. That's why in a forever loop, you can see that I've embedded two print serial monitor, one for the analog pin A0 and one for the analog pin A1. And the block print to serial monitor, actually it should be on the output categories. As you can see here, it's the print to serial monitor. Okay, so by default it's to print the hello world, but if you go and you click on the input, you can see that the blocks that you can insert in the print to serial monitor are read the analog pin, and you can specify from which analog pin you have to read. So the two blocks allows me to display on my serial monitor, that I'm going to show you in a while, the two values that are read from the LDRs. And this is very important to see the real values, because sometimes maybe our system is not built correctly in terms of hardware. That's why we have to focus and to concentrate on the idea of printing data on our serial monitor. And then we have to wait for like 1 second in order to display those information slowly. And then I'll be creating a condition, which is, I believe, very simple. If the read analog pin is less than the read analog pin A1, so here I'm comparing the values of lights to read from both LDRs. So I'll be rotating the servo to 0 degree. And then if not, I'll be rotating for 180 degrees. Here, the values are not really important since I'm doing what we call a simulation program. So, and this is what Tinkercad offers for us, is once I built my circuit, I can simulate and I can see how it will be on real before going to build the script. And for those who are asking where we can implement this project, okay, which grade level, I can tell you, you can introduce this project by the grade 8-9 in simulation, okay? And then after, I can go to in grade 10, 11, 12 by asking students to build using the hardware in order to create a real project. And here I can tell you that the solar panel that it exists on AliExpress in small size could be implemented on the servo motor. I'll be showing in a while once we move to the part of designing the skeleton of our structure. And this is what we believe it's new for students, is by merging electronics, coding, and 3D design. And this is what we call the real STEM, or the real STEAM, that you are asked in your schools to start implementing, start creating, to move forward with your students for a better place. So, so the code here is if the read analog A0 is less than A1, we have to rotate for one side. If not, we'll be moving to the other side. And if the value of A0 and A1 are equal, which is a really delicate case, so I can turn my, or I can position my my motor to 90 degrees, which is in the center. So by clicking on Start Simulation, I will hide my code. So, sorry, I have to show my code. I'll tell you why. Just 1 second to move the... All right. So by showing the code and by making my project run, you can see down on the screen there is the serial monitor button. Can you see it, please? Can you tell me if you can see it? Okay, great. So by clicking on the serial monitor, sorry, one of the participants asked me if you, Mrs. Asma, would you please use the link for the project of Tinkercad? I'll be copying it, and I don't know if you can have it later on. So I shared with you the link to the project. So here you can see that values are displayed on the screen. If I click on how my system will function virtually by simulation, all you have to do is to click or to select one of the LDRs and to slide to the right or to the left, the slider bar, and here you can see that it's shining. Shining, it means it's sun. And you can see that the value of the resistor now, it's like 61. And let me move a little bit my system. So you can see that my servo motor now it's moving according to the value of the sun or the LDRs. And if I okay. And if I click on the second LDR and I move it more, so you can see that the motor it's turning for the other side. So here what we are controlling is the rotation of the servo motor according to the intensity of light, and we consider here that the sun is moving above the solar panel, and the solar panel will be rotating and following the sun. So that's why here it's really important to visualize a little bit for the students, and I'll be sharing with you. Just give me. I'll be sharing with you. All right. Just tell me if you can you see now my screen, my video, where there is a servo motor?
Yes.
Okay. So I'll make this video in play mode, and you will see that while using my flashlight, by moving it left or right, I consider that my flashlight is the sun. So, and by the way, this video is available on our social media and on our YouTube channel. It's like it's L'Info pour tous online. It's a combination of a French word and English. So it's our channel. So you can see this video online. So you can share it with your students. So if I click on the play button, so you can see that my project in real, so according to the sun, so my motor is rotating to the left or to the right. شفت بلحظة عم يوقف يكون الليفت والرايت قد بعضهم المدورات. هون عم بيغير. So here you can see that now it's turning left, it's turning right. Now it's working correctly. Okay, so this is what you are asked to do, and by creating, let's say, by creating the circuit, and the remaining part of this project is how to build the structure in order to hold all this, at least the servo motor and the solar panel. So I will show you a design I've made on a 3D printer. All right. So this is a simple design, and I'll be explaining you how to make it as simple. This is my servo motor, where it can be inserted in our container. So this is the skeleton of the 3D design part in order to hold my servo motor not to fall down. And this is another part, which is the skeleton part of holding a solar panel that I'll be screwing on the servo motor. So imagine that there is a solar panel connected. Just 1 second, please. So imagine that there is a solar panel here, sorry. So, and it's connected directly to my servo motor. The moment the sun is here, my solar panel will turn to this side. And the moment I click, the sun is here, the solar panel will turn to the other side. So I believe now that we have to move to the part where I have to build, but before I'm going to move again to my PowerPoint, just to tell you how to take the action. Sorry, excuse me. So now my blocks are made, and we explained how to create my circuit in blocks in order to start this visualization part. And the remaining part is how to convert this script made in block to a C++ in order to copy it and to paste it on my Arduino project software. So when I click on I will stop my simulation. When I click on the block, on the code, I click on the drop down, and then I will select blocks and text. And you can see easily that the blocks are converted to C++. So here students are not obliged to start from scratch in order to write the C++. It's easier for them to make this transition. And from there, you can explain them the role of each part in order to start simulating the project. So this code, I can select it, I can copy it, and I can go to my Arduino. I don't know why I don't. I don't have. Just 1 second. Okay. So I go to my Arduino software. This is it. It's launching. Okay, I select my code to delete, and then I can paste my copied blocks in order to make this simulation or to upload the code on my real project. So imagine we don't have the time to make all this or to build it in real, but you saw the project, how it was made in the video. So I believe that if you copy this code and you go and you upload, and you go and you upload this program on your Arduino board once the circuit is done, so it will be functioning in a correct way. And the serial monitor, please here make a full concentration of this point, that the serial monitor on the Arduino software, it's like the loop here, and where it's written a serial monitor once you place your mouse on the icon. Okay, now you saw that from the blocks I've created my Arduino code, and in 1 minute I can explain you that the C++ code is divided into two parts: the setup loop and the loop procedure. In the setup procedure, I have to declare A0, A1 as input. I have to declare or to attach my servo motor. It's a syntax that I have to respect. And I have to declare my serial monitor and to set my speed of transmission of data to 9,600. This is a fixed value that it's not allowed to change. And if you read the program in the loop procedure, you will see that it's a normal program that is evaluating two values of the LDR connected to A0 and A1. So I believe that this transition is smooth and it's simple for teachers and students in order to start working with Arduino skills and STEAM skills. So now I'll be moving quickly to my last part of this workshop, which is how to move in practice to create my skeleton in a 3D design printer. So I believe that the first thing I have to do is to measure the dimension of this servo motor. If I take a simple ruler, I can, but it's not precise 100%. That's why it's very simple to achieve this mission. You go to, like I've did, and you can see, you go to Google and you set your search to the dimension of a micro servo motor S90, which is the name of this servo motor. And what is very important for me, you can see that there is many values. What is really important for me is this value and this value, the width and the height of the servo motor, which is the dimension of the base. So I believe that this is 12 millimeters, like 1.2 centimeter, and this part is like 2.25 centimeters, which is 22.5 millimeters. And from here to here, it's like 32.5 centimeters. What is important for me for this time is to know the internal dimension of my servo motor, since I'll be inserting my servo motor in this way. I have created another servo motor holder also, which is like a bigger, and you can see here there is 4 holes that I can fix it on my table or the structure I'm doing as a steam. So now my servo motor will hold in order to be attached to my solar panel. How to do my structure? It's very simple. Since now I know my values, 22.5 by 1.2, so I'll be moving to my my Arduino. I'll be hiding the code, and I go for, just 1 second. So I'll go for my main page to create a 3D design. Okay, and I'll start by dragging a cube. You can see the cube here. I remind you that by the end of this session, we will be making a draw, and there will be a winner for a complete Arduino kit with the skeleton of the servo motor and the solar panel that we will be given delivering to the school. So by clicking on the cube and placing the mouse on one of the white squares, I can see the dimension in centimeters. It's too big. So I start by making it like, I don't know, 5 centimeters. And I have to make one side 2.25 centimeters and the other 1.2 centimeters. It's too, you can see here like it's too small, but actually this is the real size. I have to make it, so this is my real size of the container of my servo. What I'll be doing, I will copy and paste another object. I will change the color just to view a little bit. I will press my shift and I will make it, I don't know why it's not changing. Oh, sorry. So I will make it a little bit bigger. So 1.6 by 3. All right. Why I'm doing this? Because the red cube or the red box will be the hole. So I'll be placing the red inside, as you can see here. I'll be taking the snap grid to 1 millimeter. All right. And I'll be taking, making it a little bit higher, like for 0.2 centimeters to make it higher a bit. And let me check. You can see now. Okay. So now my container should be the red box. I will be transforming it to a hole and then select the 2 objects. I believe we did already previously a session regarding this chapter, which is 3D Tinkercad, but it's very simple. Since the session is recorded, you can move forward and see again how it will be done. And then I will click on the button group. And once the group button is executed, so you can see that you have a container for the servo motor. Okay, now what I should do in order to print it as a 3D design, I have to click on the button export, and I have to choose for 3D print. Usually it should be like the extension STL. And once you click on the extension STL, there is a file that will be created, that you will be copying it and taking it to the software for your 3D printer, or even, so let me show you. So here my program shows the 3D object of the container of the servo motor. So this file, if you have it, sorry. So this file, if you have it, if you have your 3D printer at school, you can easily print it, and you will have a one like this with real dimension, no errors, since you started your calculation or your dimension by choosing the correct dimension from the internet. Okay, and then after, you can if you don't have the 3D printer, I believe you can take it to a library shop or a place where there is a service to print 3D objects. You can create it. Maybe there is a part missing, which is let's say which is how to make the base. So look, it's very simple. So so you can here make it, let's say here it's like for just 1 second. It's like 0. Let's say 2, and here I have to elevate this for 0.2, and to place it here to make the rotation. Where is my angle of rotation? I cannot see it. So like here, it's a kind of here it is. Okay, I can select both, click on the align, and then so here are the you can even change later on the size of your base. You can create a hole. So all those manipulation should be simple and classic for you to attend later on. So I believe, in order to cut it short, I think we have we pass a little bit the time by we exceed the time by 10 minutes, so we have to finish it in order to consider the 1 hour for this workshop. So from one side, we saw the hardware, we saw how to make the structure in Tinkercad. If you have the hardware, how to build it, how to create the mission in blocks, how to convert it into C++ in order to upload it on the board. From the other side, which is the 3D printer, so think reverse. and I'd like to show you a website for those who have and they don't know this website. It's really important, which is the Thingiverse. So this website, I will copy it and send it to you by of course I will. So this is the website where you can find any design you want. So let's say micro servo Arduino motor. So you will see that there is container. It's not this. Holder, maybe holder. Let's see. Even not this. So you can see here, look, a different kind of 3D objects with real design. Okay, so here it's better, the search, it's better. So you can see that you have here a holder for a micro servo holder. Okay. Skeleton. No, it's not this. So this website, I usually use it when I need a design, just in case I'm in a hurry, or I can build it from scratch in Tinkercad. Now I'll stop my sharing. I will stop my recording.